Okay, 5.2, students will be able to use inequalities involving the angles and sides of triangles by completing problems as taught. So here's the basic idea. If a equals b plus c, and c is a positive number, it's some number greater than 0, and then a has to be greater than b. It's kind of like this. Imagine that you have a $2 bill, or $2, and you have $3. Well, if you add that up, right, it equals $5. Okay, well, let's say you take away the $2 bill. You take away one of those two parts that made up the whole. Well, then right away you know that if you still have the $3, it has to be less than that $5 that you had. It has to be less than the whole. Okay? That's all this theorem is saying. So if a equals b plus c, $2 plus $3 equals $5. Then c, one of these parts, like you could say, and c is greater than 0, so either one of these, in this situation 2 is our c, it's greater than 0, then we know a has to be greater than b. A and b. A has to be bigger than b. That's how that kind of plays out. Alright, so it says let's prove it, but that's actually something we're not going to do here. It says recall the triangle exterior angle theorem. The measure of each exterior angle of a triangle equals the sum of the measures of its two remote interior angles. Okay, remember we said that. We said, like, for example, in this triangle here, we could say, hey, angle 2 plus angle 3 equals angle 5. I called it angle 5 just to make more sense, so it kind of fits our analogy. 2 plus 3 is 5. But these are not values, remember. These are just numbers. But I just thought it'd fit a little bit better. So that was the remote interior angle theorem. It said, hey, if you got two angles on the inside, they equal that angle, that unattached angle on the outside, the one that these two angles are not touching. Well, the corollary to the triangle exterior angle theorem uses this comparison property of equality, and it says the measure of each exterior angle of a triangle is greater than the measure of each of its remote interiors. So angle 5 here has to be greater than 2 or 3, since 2 plus 3 equals 5. Alright, that's the basic idea. And so we're going to take that to this next situation here. It says, explain why the measurement of OTY is greater than the measurement of angle 3. Well, let's think about this. OTY is this whole angle that I have marked here. And we have to explain how we know for sure that it's bigger than angle 3. And we can't just say it looks bigger. That's not what we do in geometry. But we do know that 3 plus 4 would be equal angle 1 because we have two interior angles. We'd have to equal angle 1. Therefore, if we were to just get rid of 4, we could say 3 has to be less than angle 1, since 3 plus 4 equals angle 1. So we could start off with that. We'll say, hey, we know that angle 3 is less than angle 1. And, hey, we know that angle 1 is congruent to angle 2, because look, it's an isosceles triangle. So angle 1 is less than angle 2, well then that means that angle 3 is less than angle 2 as well, since 1 and 2 are the same. Alright, well look at here. 4 and angle 2 make up OTY, therefore angle 2 must be less than OTY. So we'd say that. Angle 2 is less than angle OTY. Well, if angle 3 is less than angle 2, and angle 2 is less than OTY, then angle 3 has to be less than angle OTY. And if we wanted to, if we were doing a proof, we would write reasons next to each one of these statements. But we're just kind of explaining why we know something, so we don't really need to do it as a proof, a formal proof at least. Alright, next page is theorem 5.9. Let's take a look at it. It says if two sides of a triangle are not congruent, then the larger angle lies opposite the larger side. I kind of forgot to hit enter here and put that theorem 5.9 right there. And then theorem 5.10 says if two angles of a triangle are not congruent, then the longer side lies opposite the larger angle. So these two are kind of just the reverse of each other. And here's really all they're saying. I mean, if you were to look at these three angles and these three sides, you could obviously say that BC here looks like it's the biggest side. Well, that means that this angle is the biggest angle. Okay, well, AC looks like it is, I'm sorry, and that's because it's opposite. It's the angle that is not touching. Okay, I've explained it like this before. Imagine you have Pac-Man, okay? And when Pac-Man isn't very hungry, his mouth is not open very much. So the angle here is really small, and this distance is really small. But when Pac-Man's very hungry, the distance here is a lot bigger, and this angle is a lot bigger, right? So how far open this angle is will also determine how far apart these two edges of the angle are. So the farther open the angle, the farther the distance is. So that's kind of a way that I've explained in the past. So let's take that to this next side of the triangle here. Well, this side AC is obviously the second biggest side, and that would make this angle the second biggest angle. And then lastly, AB is the smallest side, so this is the smallest angle. Alright, so if they wanted us to list these, we would do sides and angles. And let's go from, they said from largest to smallest, okay? Well, the largest side we said was BC, and then the next one was AC, and the smallest one was AB. Alright, and then if we were to list the angles, again, the largest angle we said had to be angle A. And then it was angle B, because that was opposite the middle side. And then the smallest angle is angle C, which is opposite the smallest side. Something that's really interesting to notice, look, when I'm talking about BC, the angle that we're talking about is the letter of the triangle that's not included in BC. So remember, I have three letters, A, B, C. Here's two of those letters, BC. This is the missing letter, A. Same thing here with AC. What letter is missing? Well, look at that. It's the angle opposite of it, angle B. Here's a side, AB. What angle is missing? Oh, look at that. It's angle C. And so, in theory, we should be able to tell which angle is bigger without even looking at a triangle. So let me show you another idea. What if I was to go over here, and I was to say, hey, sides, largest to smallest, and these are the angles, and I was to tell you that it's for triangle PQR, and I was to tell you, hey, PQ, that's the largest one, and then QR is the medium one, and then the smallest one is PR. Well, you should be able to look at this and write down the angles in the same order, largest to smallest, just from this information. So why don't you go ahead and try that, just off on the side somewhere, and I'll put the answers up in just a second. You can go ahead and pause the video for a little bit. Okay, well, hopefully you saw, hey, the letter missing from PQ out of my triangle PQR is angle R, so angle R must be the largest angle. And then the letter missing from QR is P, so angle P must be the middle one, and the letter missing from P and R is angle Q, so angle Q must be the smallest one. And that's really all there is to it. I'll just shrink that down, move it over, and that's really the end of these notes. See you guys next video.